Hi, I'm Hannah. I'm a tutor at Sky Academy, and we're in the topic of measurement within the Year 11 standard course, and we are looking at perimeter, area, and volume, which comes under MSM1. So in this video, we're going to have a look at the volume of composite solids. So this is applying our knowledge of volume of random shapes to real life applications. So when we're doing the volume of composite solids, you need to divide the solid up into separate groups. So if you're doing a cylinder and a rectangle, you can't find the volume for both of them combined. You'll have to do the separate volume for a cylinder, then the separate volume for the rectangle, and then add them together. And then you need to write the answer to the level of accuracy specified. So because we're in volume, it needs to be to the unit cubed, so it could be meters cubed or centimeters cubed, for example. So let's have a go at doing an example. So here we have a question with a silo on a farm. A silo is where they store like the wheat or the grain or the food on a farm, and it is in a cylinder shape with a cone on top of it. The radius of the cylinder is 8 meters and has a height of 20 meters. The radius for the cone is also 8 meters and has a height of 2 meters. Find the volume of the silo. So they've already kind of broken it up for us. We have a cylinder which looks a little bit like this, and then we have a cone on top of it. So this is going to be the shape of our silo. This part is going to be our cylinder, and this part here is going to be our cone. So we can see that we need to break it up into 2 steps. First, we'll find the cone volume, then we'll find the cylinder volume, and then we can add them together. So we're going to find the volume of the cone first. And we know volume of a cone to be 1/3 AH. And remember, our A is the area of a circle, which is here. And the area of a circle is going to be pi r squared times by the h of the height of the cone. So our volume, if we sub in information for our radius and our height, the radius for the cone is 8 meters and the height of the cone is 2 meters. So putting that into our calculator, we should get an answer of 134.04 meters cubed. So now let's do the same steps, but for our different shape for our cylinder. And the cylinder volume is going to be pi r squared h. So it's going to be volume equals AH, but our area is once again the area of a circle. So our area is going to be pi r squared, and then we're going to times it by our h. Might just draw a line down there. There we go. So now we can sub in information for our radius and our height to get an answer. So pi times the radius squared. The radius of the cylinder is 8 times by the height, which is 20. So when you put that into your calculator, you should get a volume of 4,021.24 meters cubed. So now we've got the volume for the cone individually and the volume for the cylinder individually, but we want the entire volume of the whole entire silo. And so we need to add the cone and the cylinder together. So then it will be 134.04 plus 4021.24, and that's going to leave us with a total of 4,155.3 meters cubed. Don't forget to add in our units still. Although we're doing a real life example, we still need to include the units of meters cubed or centimeters cubed or whatever units your dimensions are in.